And here we are again. So we have all these stuff for the encryption stuff. So we have basically all we need at this point. We have key functions, like generate keys, and encryptors, which includes decryptors and an encryptor. So basically that's all you really need. But since we want to be able to use this over and over again and remember our keys and send out public keys and private keys, we're going to do these we're going to have this thing called a key maintenance function where we're going to come through here and have a master DB. So I'm putting this in code right for right now. A master DB, which is going to have everything about the keys. It's going to have the prime numbers. I'm going to keep everything. It's going to be private. I'm going to lock down that database so no one else can see it. If anybody got to it, they would have access. This is the private element of stuff. And then we're going to spawn stuff into this master DB, and then we're going to cut out parts of that key to this public DB that'll have just the public aspect, basically PQ and the D value, or sorry, not the D value, the E value, along with some stuff like the strength of how many bits the key has and whatnot. In order to do this, we're going to need to create some databases, which I've already done. I'm going to name one key store, which is going to be my private key store, and then the sec store, which is security store, which is going to have my public keys, and I can store things maybe like passwords or other encrypted stuff in here as well, because you can't decrypt it with that. But in order to do this, I need a table, which I think I've got let's see if I remember where I put this. Of course, I don't have this in the right place. root scripts Python, not Python, SQL Server, encryptions, create a key store table. So I'm going to create the key store table right here. If it actually loads, and it's just going to have an identity ID 1 through a billion trillion. The data was created, digit length, key bits, and the actual key, which I'll store as a binary. So let's run that. Boom, done. If I click refresh, I should have my keys right there. Select top, blah, blah, blah. Now the next one I want to do is for the sec store, because the script we're going to do is going to create keys, it's going to dump it into this into the private database, and then it's going to strip it out and put the other part of it into the public. So we have basically the same structure. Of course, there's no identity on that one because we're copying it from there, and we'll identify the keys by this ID. I mean, maybe we should have it like a GUID or something, so we can, or something that tells you where the key comes from. I'm not really concerned about that at this point, but we'll see where it's in the security store. And we come here, refresh, and there we go. Okay, good. So what are we doing here? So this is just configuration for the database. I'm going to have how do I connect to the database on both of them. My SQL statement is going to be basically my how do I get to my key table. This should be pretty much the same. How do I insert something into a key? I'm going to use PyODBC or some variant of that to get something in here, and then the select key is how do I pick an individual key, because we're going to want to be able to pick one key when we actually have this in operation mode. So let's just go through these functions. Write keys to DB sec store. This is going to take a key list. So we're going to use the key generation we did from key functions, generate them, and we're going to pass that list to this guy along with the database function, database config function, which is just going to go through and for each guy in this key list. I guess why I'm pulling this apart this way. Okay, yeah, I'm taking away the key list, and then I'm adding create date and the binary object, which is the pickled key to the stuff. If you're interested, looking back up here, the insert statement is literally insert into sec keys, create date. It's just standard SQL using the question mark as placeholders for the list of lists that are going to be put in here. And that's really just it's going to take the keys that we generate and put them, and once the keys are generated, we're going to dump them to the database. This guy next one, maybe not necessarily good order, but we're going to return a random public key. So if I want to create a new encrypted something, I'm going to ask the public database for a key. So it'll just go in there and from the number of records that are in there, from 1 to the maximum ID count, pull up a number and then say that, and then get that key back from that data store and return it. This is something to encrypt with. See, it sends the ID and read a single key from the key store. It can be from the public or the private. I'm assuming most of these are going to come from the public because you're encrypting stuff. You will be encrypting stuff, but it takes the ID of the database table. In this case, remember, this thing doesn't have anything in it yet, and it's going to return that key information for you, so you can start encrypting stuff. And we'll walk through one iteration of this, and then this guy is going to, once you have, well, we'll see what happens. Once you have the private stuff all put in place, we're going to take those private keys and then strip out basically P, Q, and D and put it into the public space. So public keys, public private key encryption right there. And I have the stubbed out function, stubbed out name only. You could also write this stuff to a file if you want, file of key stores. It's important to keep to remember that guy has to be secure. Keep these two things away from each other. If it's on a database, make it so that no one but your program can get onto there and suck stuff off of there. I mean, this is the epitome. You're going to have to lock this down with SQL Server. If it's a file share, you have to lock the file share or the directories down as well. Easy to do. This one's more easy. This can be off on some other database somewhere, and whomever you want can look at it. Of course, you want to talk about signing, but we're not at that point yet. So let's just forget about that part for right now. Let's walk through one of these guys at this point, and we're going to generate. I don't know what I'm generating yet. I'm going to click the go button. Okay, start time now. I'm getting 10 keys, and I'm going to generate 10 of these things. I'll put a breakpoint there and tell it to go. That was a little too fast. What happened there? Something went wrong. How come I don't have all these questions I'm asking myself so you don't have the answers to? Oh, it's still running. I'm sorry. I kept stepped over. It's still running. It hasn't actually stopped on this point yet. We'll give it a couple seconds. I want to also note here that I'm doing 500-digit prime number and a 501-digit prime number. So that's a little bit larger than I think in our last example. We did 100 and a 200. For some reason, this one just doesn't. It doesn't. Just slows down massively. It doesn't do that on real. Oh, look, I'm 100% CPU. Woohoo! Oh. Is it really all this stuff? Oh, look, it's going. Maybe future video we could talk about multiprocessing and making this go a little, although it's 100% for each one, maybe that's at its limit. Oh, and I just remembered I didn't fix that other bug from this thing where we had, where was it? That's just my counter. If it's greater than break, so never is going to count up. Deal with that one at some point. Oh, and look, it finally got to it in a couple minutes. That was gruesome. But through the time-lapse photography, you don't have to watch it. So I'll just keep stepping through this guy. It made it. My kilos are right here. Woohoo. Look, I got a list of them. And what am I going to do next? I'm going to write these to the sec store. Security store right there. And it's not that exciting. I'll put a breakpoint in there just for fun. Here. copy the return value. Here's when I start. Here's my, what is this thing called? Oh, I'm going to append to this list. And it's just going through and it's creating my list of objects. Remember, we could have taken this list there, but we wanted to append a create date and a digit length and this stuff that been object. The magic is right here on this update SQL. I'm going to connect to this database there, which we'll look at right here. It's on Sexstore, so let's see, how many do I have? Let's just close these. Anybody else frustrated by the SQL Server tabbing? It's probably just me, right? So there's nothing in this guy right now. We're in the key store, not the Sexstore. I said Sexstore over here. I'm going to run that. I'm not checking the result because I'm lazy, but it came out as true. Return result. If I come back over into here and I hit enter again, I should have 10 entries, and there they are. And remember, we're taking that key and we're putting in binary to store it as a max binary object in SQL Server. Yahoo, that worked. And what are we doing here? We're going to write the public keys to we're going to take the private keys and write them to the public. I need better naming for my functions. Oh well. But here we go. With that, we're going to return everything from the key store, and there they are right there. It's going to be in payload. Check to see if it works. If it worked, I'm just going to put payload in master keys. And if it's less than one, whoops, nothing to transfer. We're going to go through. Hold on, before we talk about this, let's go down to this guy again. We're going to put things into here, and there's nothing in there right now. But since this is public, we're going to want for each one of our master keys here, row in the master keys, we're going to take this key, unload it, unpickle it. Unpickle, is that the right way to say it? Deserialize it, unmarshal. And we're going to remove the P, remove the Q, and remove the D because that's not part of the public key. And the key now looks like, we'll even look at it right here, key right here. Key. I got a 1,000-digit key. It's a 3,300 bits. There's PQ. There's E. And that's all there's in there. So we want to be able to, so we'll repickle that back up, bend it to there, and we're just going to come over and let that do that until it takes all 10 of those things and goes. So at this point, we can now come over. We haven't done the query yet, but we're going to say, okay, go do the update. Where this time we were checking to see if it worked or not, and it did because it didn't go over. No, we truncated first. Sorry, guys. We truncated the table over here because, you know, for rewriting the keys. Now this, if you have, obviously you have to be careful with this. If you have this in use and you truncate the keys, and you just ruined your whole security stuff, but I'm not worried about it. So it truncated fine, and then I'm going to write the results. I'm not checking for that, but if I come over here, I should now have the paired up public keys right there, and yes we do. And we're just going to test. We're going to read a key. We're going to read the first key from the database. It's going to select it. It's going to unpickle it. It's going to return the result. And I'm going to print the result. And the result should be right there. And here it is. So the whole thing returned from there in the payload right there. This is our key, the first one we wanted. Now we're going to read a random key. No, we're going to read, we're going to do the same thing with the pub. We're going to pick the same key. We're going to do, I see what I'm doing, from the key store and then from the public sex store. And we're going to print that. We'll just, on these two lines here, see if they're the same length. See that the second one is from the public, and it doesn't have the same amount of data in it because it's not needed. You don't want to see it. And I print some wonderful information. It took that long to run. Yikes. And return a random key. Woohoo. And I just picked a random key. I picked 3 of this guy. And that's it. That's the video. So we now have a way to get and retrieve data to a database, a persistent storage for both public and private key entities. We have key functions to create keys on the flies and stuff to encrypt. Next things we're going to go over are the actual encryptors and the decryptors.